Just a moment. I think we are live. Yes, we are live. Just a moment. Okay, so this is the fourth preparatory preliminary webinar to the fourth World Congress of SRI, and our guest today is Joe Pelton. He will give us a very interesting lecture about life protection from cosmic radiations and shields that can reach this important goal. So the floor is to Maria for an introduction, and then we will attend this lecture. Maria, please.
Yes, good evening, everyone. Thank you, Adriano. So, to give like an abstract about our topic tonight, we usually know that the sun is the source of life on Earth and it supplies Earth with thousands of times the amount of energy we use. Yet, solar winds and radiation, and especially coronal mass ejections, if were to be as powerful as the Carrington Event of 1859, could wipe out much of the world's electrical power grid system and perhaps even take down the internet. Lloyd of London estimated that a Carrington Event solar storm would require $3 trillion to bring back just the North American power grid. Mars, unlike Earth, has virtually none of its magnetic field protection left, and thus the solar wind alone strips away its atmosphere. There have been studies by NASA and other research institutes that have examined the possibility of creating magnetic shielding systems for Mars. This would use a combination of artificial satellites as well as Phobos and Deimos that could create a complex combination of magnetic shielding system that could allow the terraforming a 3-satellite network deployed by ESA and 4-satellite network deployed by NASA has confirmed that the Earth's magnetic field is in the process of reversal. Thus, the North Magnetic Pole is moving down to Siberia, and the South Magnetic Pole is moving up towards Australia. Computer modeling has suggested that during the reversal period, the Earth's magnetic field might be reduced to 15% of its protective shielding strength when the reversal is halfway complete. Earth has no suitable low-orbiting satellites, so a magnetic shielding system would be dependent entirely on artificial satellites. Such a network would be expensive to deploy and maintain its operation, but it could potentially ultimately make Mars habitable and natural oceans and could save Earth from a devastating coronal mass ejection that could have devastating economic impact where billions of jobs might be lost and trillions of dollars would need to be spent to restore electrical power grids, pipeline controls, the internet, and communication networks and other vital infrastructures. Former NASA chief scientist James Green and SRI Vice President Joseph Pelton jointly are carrying out research in this area to explore design architecture for magnetic shielding systems starting with Mars. So, who is our speaker tonight? Joseph Pelton. He has a PhD. He is a chair of the board of the Alliance for Collaboration in the Exploration of Space, ISS Worldwide. You can also check the website ssworldwide.org. He is the Dean Emeritus and former chairman of the Board of Trustees in the International Space University. Dr. Pelton is founder of the Arthur Clarke Foundation and the founding president of the Society of Satellite Professionals International, now called SSPI. He serves as the vice president of Space Renaissance International. He's the president of the International Space Safety Foundation. He's the president of the Global Legal Information Network. He was director emeritus of the Space and Advanced Communication Research Institute at George Washington University, where he also directed the Accelerated Master's Program in Telecommunications and Computers. Earlier, he headed the Interdisciplinary Telecommunications Program at the University of Colorado Boulder and held executive posts at ComSat and Intelsat, where he was Director of Strategic Policy. A prolific author and futurist, Dr. Pelton has written some 70 books and over 400 articles, including works nominated for the Pulitzer Prize. He has appeared on PBS, NPR, ABC, CBS, BBC, CBC, and FR3, and has spoken before the US Congress, the United Nations, and audiences in more than 40 countries. His honors include the Sir Arthur Clarke International Achievement Award, the Arthur C. Clarke Foundation Lifetime Achievement Award, the Da Vinci Award of the IISS, the Garden Award of the Lifeboat Foundation, the ICA Educators Award, and the ISCE Excellence in sorry, I just mistake this, in Education Award. He is a fellow in the IASSS, Associate Fellow of the IAAA, member of the SSGI Hall of Fame, and an elected member of the International Academy of Astronautics. His recent books include Space Systems and Sustainability, Future Challenges for NASA Space 2.0, The New Gold Rush, Global Space Governance, and the Handbook of Space Satellite. Dr. Pelton received degrees from several universities as University of Tulsa, NYU, New York University, and Georgetown University, where he got his PhD. I leave
So
the floor for Dr. Pelton, and we are all ears.
are we finished?
Yeah,
Thank you very much. I should have sent a shorter bio. So
it's fine.
thank you very much. So can we have the first slide, Adriana?
Yeah, sure. We just let me share my desktop. Okay. Sharing. I think here.
Yes. All right. So just go to the next slide then.
Please let me go full
Right.
screen. Just a moment. I have to go full screen. Yep. Okay. So
yes, perfect. So as we heard from Maria, the sun is very important to us. It supplies us a tremendous amount of energy and light, and we could not exist without it. But it also is a source of some danger to us. And so let's go to the next slide. So the sun emits energy and hazards in many ways. You can see on this slide that there are sunspots, which indicates magnetic disturbances that can lead to releases of flares, which is radiation. And that radiation can be ultraviolet light and even X level flares and so on. And those are dangerous to our health in terms of sunburn, but also it can lead to skin cancer. And also, as we are seeing in the southern South Pole areas, genetic mutation to frogs, and that this is certainly a source of some danger to animals and to humans. But with each flare, about 50% of the time, there's also ejections of ions. And there is, if you will, all the time a release of energy known as solar wind in terms of ionic particles. But when there is what's called a coronal mass ejection, we have huge amount of mass ejected from the sun. And when that occurs in this kind of a dangerous solar storm, this can impact the Earth if it comes in our direction, and that can create great dangers to power systems, to electronic control systems for pipelines, for satellites, and of course that impacts the internet and electric devices and so on. And this was noted earlier by Maria in her opening abstract. Let's go to the next slide. So when we have these kind of magnetic coronal magnetic mass ejections, it impacts us. And as you can see in this diagram, not to scale, of course, that it pushes the magnetic field on the incoming down and flattens it, and it pushes it out to maybe even 20 Earth atmospheres out away as these trillions or quadrillions of ions smash into the protective shielding of the Earth's magnetic field. Next slide. So this, of course, is what happens to Earth, but when it comes to Mars, which has no magnetic field left, or virtually none left, even the solar wind strips away the Earth's, the Mars atmosphere, and particularly when there is a coronal mass ejection that hits Mars, it really takes away a huge amount of the very small atmosphere that's left on Mars. But as you can see here, this is a depiction of the Mars ice caps, and there is a substantial amount of frozen water on the Mars ice caps, and enough to actually creating at least a thin ocean on the surface of Mars if this were to melt. And so we're going to be talking about, could we create, using artificial satellites, a protective magnetic shielding system that would allow Mars to actually build up an atmosphere, and that eventually, if this could happen, could Mars actually be terraformed and create a breathable atmosphere and the ability to undertake agriculture on the Mars surface. Let's go to the next slide. So as I mentioned earlier, flares occur, and they occur on a cycle, and this releases, in many cases, X-level flares that are rated 1 to 5, and that when you get up to an X5 level, this really could create dangerous situations that I mentioned in terms of sunburn, skin cancer, and even genetic mutations. Next slide. This actually is the sketch that Carrington met when he was actually a solar astronomer, and he was observing the sun through a mirror reflection, because he was not looking directly at the sun, and he saw this huge dragon-like shape occur, and he called everybody who was downstairs, and they all sort of amazed to see this huge area of the sun. And about a day and a half later, that mass ejection, traveling at millions of miles an hour, hit Earth. And when that occurred, the so-called Northern Lights came down to Cuba and Hawaii. And at the time, in 1859, there were only telegraph offices using electricity, but the radiation was so strong that paper in telegraph offices caught on fire. But today, of course, we've come a long ways in terms of our use of electrical power systems to run our society. And so we have electronic grids that are vulnerable, and transformers could be burned to a crisp. And as mentioned earlier, the Lloyds of London, with a group of physicists, concluded that there would be sufficient damage to the transformers, just say in North America, that it would take up to $3 trillion and many years to replace these transformers. And of course, there are things that can be done to protect transformers, to have more heavy-duty surge protection systems and other kinds of electrical devices installed to prevent the destruction of transformers. But unfortunately, around the world, few of these protective systems that could really defend against a Carrington type event are in place. And there are, if you will, dark swan studies that are done by various ministries of defense and intelligence agencies. And such a Carrington event solar storm is actually one of the dark swan events that could have a crippling effect on the global economy. And actually, there would be, if you will, an avalanche of effects of unemployment, because so many people's employment depends on the availability of electricity in a service economy. So anyway, Carrington event seems to be something that could happen about every 150 years. There is history going back, recorded history in China that indicated around 1700 there was a similar event with a massive impact, and the so-called aurora events coming down from the North Pole and up from the South Pole to be seen almost to the equator. So if this is a truly accurate forecast, we're overdue for another Carrington event, and have really little protective capabilities in place to deal with this. So let's go to the next slide and look at the situation of Mars. And as I noted earlier, it's lost most of its magnetosphere, but that there could be various ways, perhaps doing it on its surface by creating smaller magnetic fields to protect a habitat, or it could be done on a planetary scale, which would be, of course, a much more difficult thing to do. But what we do know that Mars gravity waves and melting of ice caps continuously is creating a thin atmosphere sufficient for, say, be able to fly a kite, or even have a small winged system fly in the Martian atmosphere. But it certainly is not protected from solar ionic particles, the solar wind, and CME events. Next slide. So people say, well, gee, if this is only every 150 years, do we really have to worry about this? But we have actually coronal mass ejections happening all the time. One of the biggest ones happened in 1989, and it was known as the Montreal Event, but it took out power from Chicago all the way to Montreal. And here you see a transformer in Chicago, what it looked like before the Montreal event occurred, and here's what it looked like afterwards. So as you can see, even a smaller level coronal mass ejection can still be quite powerful. And we had in October of, I think it was 2008, it took out power in Scandinavia and so on. But these smaller solar storms are more focused and would not be as widespread and catastrophic as a Carrington level event. Next slide. So CMEs, as I say, are very powerful events. And here is a depiction that captures the event much more vividly. And as you can see, there's that very small sphere in the middle of this event, which is Earth. And as you can see, the compression that occurs to the magnetic field and the so-called Van Allen shaped protective shielding around Earth, and how the magnetic field is blasted out 10 to 20 times Earth's atmosphere by this blast of quadrillions of ions. Next slide. So we need to go on. We're already on that one. We're going backwards. So anyway, here we're now looking at Mars and what we could do in terms of creating some sort of a magnetic field of protection. Mars has two moons, and these are Deimos and Phobos. And it's thought that we could actually use these two moons as a source to generate a magnetic field that would also be supplemented by artificial satellites to create a protective shielding system around Mars. Let's go to the next slide. So this shows you the magnetic field strength for Moon, Mars, Earth, and actually for deep space itself. And the magnetic fields are measured in what are called Teslas. And there actually is some magnetic field strength even in deep space, but it's, as you see, 2.6 nanoteslas. And the moon, which has lost almost all of its magnetic field, is down to 300 nanoteslas. The magnetic field of Mars varies from 300 nanoteslas up to 5 microteslas. So it has more protective shielding than the moon, but still very low. And then there's the magnetic field strength of Earth, which is 30 to 60 micro teslas. So the magnetic strength of Earth is up to like 12 times stronger than exists for Mars. But even there, you can see that it varies between 30 to 60 microteslas. And it's weakest at the equator and, of course, stronger at the polar areas. But as I noted, or was noted in the introduction, we are seeing a reversal of the magnetic poles of Earth, and that that this will be changed as we see the magnetic poles shift from north to south over the next 40 years. Let's keep going. Next slide. So here are the characteristics of Deimos and Phobos. As you can see, Phobos is almost 10 times larger in mass, and it also is closer to Mars' surface. So it would be the primary place where we would try to generate a large magnetic field strength system that could be used to protect Mars. And that we also use Deimos, which has a kind of equivalent of a geosynchronous orbit, not quite, but close to the rotational speed of Mars. So it has some advantage in that regard. So, and as you can see, these are pretty small events. Actually, I was on what was called the Voyage Beyond Apollo, where we went down to see the last moon shot to the moon, Apollo 17. And one of the speakers on it said that baseball could be played on Deimos, and the way you do it is that you would hit the ball at about 30 miles an hour, which is orbital speed, and about a half an hour later, you would then hit the ball back the other way as it came back around the orbit of Deimos. So interesting sport one could play on Deimos. But anyway, let's keep going. So Jim Green and I have been working on this, and he has been working with some of the major research centers in the US, as well as NASA scientists, and have come up with a concept of how this might be done. And the 40th anniversary of the Challenger Center is coming up next year. And as part of the celebration of that, the Challenger Center, which teaches STEM exercises for aspiring astronauts and people who are interested in space, will be sponsoring a hackathon contest. And one of the challenges would be to come up with ways to deal with dirt and debris storms on the moon when jets or rockets are coming in and landing on the Earth, and dealing with dirt problems with regard to astronauts living on the moon. But the other one would be to create a field system of dipoles that could be created to create a magnetic shield for Mars. And the interesting thing to me is that if this exercise is successful, and we do have some brilliant young people who come up with a really good design system, we might then in the following year do a hackathon contest to see what we might do to create a shielding system for either the moon or Earth, to protect Earth from a massive Carrington event, particularly as the poles reverse over time, or for moon to be able to start to try to create some sort of atmosphere on the moon. Next slide. So we do have satellites measuring the Earth's magnetic sphere, and ESA has a 3 satellite constellation called SWARM that has documented the reversal of the magnetic poles that are occurring. And NASA has a 4 satellite constellation now up, known as MMS, that's showing the same results in terms of the magnetic pole reversal. So this here shows the the orbits of the satellites that are being able to measure the changes to the Earth's magnetic field over time. Next slide. So this is a simulation of what the protective shielding is of the Earth's magnetic field as it currently stands, and then what it would look like as this reversal comes to its most extreme point, where the poles are, if you will, working against each other and creating distortions in the magnetic field that protects Earth from solar wind and from magnetic mass ejections. Next slide. So there is a huge number of satellites actually up and operating. These are largely NASA and ESA, but there are also some from Japan and so on. And the exact mechanisms within the sun that makes all of these events occur have been studied for some time, and we know that there are these magnetic loops that snap, and when they snap and then reconnect, that's what gives rise to the flares, the radiation flares, as well as about half the time a coronal mass ejection. Of course, in most cases, these so-called CMEs, coronal mass ejections, go off in different directions and do not come to hit Earth, or for that matter, hits Mars. And of course, Mars, to create a protective system is much easier, because Mars is much further away from the sun and it's also much smaller. And so creating the magnetic shielding system for Mars is a much easier thing to contemplate. And it also has moon systems that are in orbits that could be conducive to create the protective capability. But NASA has just launched 4 new satellites that will be studying the sun and its internal dynamics. But we still don't know all there is to know about the sun. Next slide. And of course, the sun's activity does follow, and has followed for many years, a solar minimum to solar max cycle that goes 11 years from solar max to back to solar max again. And that also, even these 11-year cycles vary over time. And we don't really know what is the crucial set of circumstances that could lead to a truly massive coronal mass ejection like the so-called Carrington Event. Next slide. So this is just one of the solar storm probes, the Van Allen solar probe that's currently up and helps us. And if you really are interested about solar storms and also levels of flares and so on, NOAA, the National Oceanic and Atmospheric Administration, has what's called a dashboard, and you can go and see the level of solar wind, or even if there is a coronal mass ejection. Actually, just a few days ago, from the 13th to the 16th, there were three so-called auroras that were coming to hit Earth, and actually the northern lights came down to basically the U.S.-Canadian border, not so that we could see them in the Washington, D.C. area, but actually these events are happening all the time, and that during that period from around the 13th to the 16th, we had a very strong series of auroras hitting Earth. Next slide. So, the creation of a solar shielding system for Mars has certainly key advantages over doing this for Earth. It's smaller, it's further away from the sun, and it has a much smaller area to protect. The two moons could be used perhaps in conjunction with the artificial satellites to create a protective shielding system. If you are interested in knowing much more about the mechanics of how you might actually generate an artificial magnetosphere, there is an article by R.A. Bamford. Jim Green is also a co-author of that article, and that was published in 2021. And in this, the Phobos lower orbit period of 7.66 hours was chosen as the prime area to use, with Deimos with its 30.35 hour possibilities could be a secondary source, plus other artificial satellites to complete a system that, if operated for several decades, the thought is that during this period, the ice caps of Mars could melt and create an ocean, and be able to start to grow crops and terraform Mars on a systematic way. So rather than living in underground habitats, we might actually be able to use these magnetic shielding systems to create Mars as a second place where humans could live a rather interesting life. Of course, the gravitational field is only about a third of that of Earth. So we would be super athletes in that kind of a gravitational system and so on. But anyway, I refer you to the R.A. Bamford How to Create an Artificial Magnetosphere for Mars article in Acta Astronautica, and that was published in 2021. Next slide. So there are a series of technical possibilities. They are numerous, from plasma generated to create an artificial Van Allen belt to supplemental activities by artificial satellites with electrical power to generate magnetic fields to create a systematic field design to protect Mars. We have no idea how much it would cost and who would pay for it. And the thing is, I'm reasonably sure that for much less than it costs to do the Artemis program, to explore the moon, or some of the other major programs that ESA and NASA have done, could be far less. And in some ways, an investment like this, in my view, would be like the U.S. and the Louisiana Purchase, where it doubled the size of the United States by paying some millions of dollars to France. That I think that a few $billion to be spent to create a magnetic shield for Mars might be quite an interesting investment for humankind to undertake. But the question is, who would undertake it? Would it be a consortium of space agencies or some sort of private commercial space involvement working with governments, a consortium of governments? And the real question is, this is something that it's not just a 1 year or 2 year undertaking. This would be having to sustain this for decades and to do it with a reliability enough so that it can support a space colony on the Martian surface. So there are many unknowns. Jim Green and I are publishing an article on this that's currently available on the publication is called Frontiers in Space Technology, and there's a special issue we're doing on living in space. We're also on the 13th of November having a workshop that there are a number of people who are working on our Living in Space initiative that's co-sponsored by my organization, ACES Worldwide, as well as Space Renaissance International and 12 other organizations. So if you are interested in what we're doing in living in space, just go to www.living-in-space.org. So that's living-in-space.org. And you can enroll to see this workshop that will be covering everything from how to terraform Mars using magnetic fields to the latest in terms of techniques to sustain human life and the medical and health issues involved living in space, to the latest information on nuclear propulsion for interplanetary rocket systems, to a whole host of other issues, including legal and regulatory issues and health standards. So that's, I think that's the last slide. Do you have one more? So, yes, the magnetic shield for Earth. So it would be much more difficult because the moon is too far away to be useful, and the network of satellites would have to be much more extensive. Ground laser generated augmentation to Van Allen belts might be more feasible for Earth. Ownership and operational controls will be very difficult to work out. The UN Committee on the Peaceful Uses of Outer Space can't even come to agreement on space traffic management and how to deal with space debris. And this would be a much more difficult thing to work out and get agreement of how this will be owned, operated, and made secure to last for many decades. So the big problem in my mind is that the risk of a planetary disaster that could come from a massive Carrington event is not fully appreciated. I've noted already the Lloyd's of London study that's just for North America and not the world, and would take years to restore. And I've already noted that this article is coming out for the space technology, frontiers in space technology, and also I've given you the Living in Space website to enroll if you want to see some of these presentations on the workshop on June 13th. So I do believe that's the last one. So I think we have time for questions or comments. Back to you, Adriano.
Beautiful lecture, Joe. Thank you. Thank you very much. It's very interesting and informative. And yeah, of course, if we have, I don't know, Maria, if we have any question from the audience. If not, I have several questions personally. Maria, hello.
Why don't you start with yours, and hopefully Maria will come back.
Yeah, I know she is connected, but
Well,
yeah.
she's muted.
Yeah, I'm asking to unmute.
Why don't you start with your question?
Yes, I will go now, right now. Yes, let me change to multi-speaker view. Okay. So, yeah, yes, I took note about my some of my questions while you were speaking.
Yes.
And hello, Maria. No, I was going to give my questions to Joe, but if we have questions from the audience, they have the will come
Yes.
free. Sorry, there's maybe your telephone.
Yeah, I'm trying to turn it off.
Okay. So maybe I will mute you then when you
No,
have to.
it's through.
Okay, you have done. Okay. So yeah, Maria, do we have any questions from the audience? They should come first.
There's a phone. Yeah. There's nothing. So on the.
No, not yet.
I think maybe Adriano.
Maybe Jerry is writing something.
Oh.
No. So yeah, Jerry is questioning about the
Yeah.
gravity issue. That
So
is not.
Jerry Stone. Yeah.
That's
Yeah.
not the
So he's
subject
asking
of
what you've described
today.
will be very
However,
important.
this gravity.
I'm sorry, I didn't hear you.
Yeah, Jerry Stone is writing what you have described will be very important for a settlement on Mars, though it doesn't cover the medical consequences of living under one third G. What are your thoughts? Yeah, this is a little bit out of the scope of today webinar. However, of course,
Well, but it's an interesting question of that. What we're discussing on November 13th is the idea of creating a space habitat with a full 1G gravitational field. That's by Werner Grondel. And basically, the only way off Earth that we can get what would be, I think, what would be a normal physical fitness environment would be to have a artificial gravity, the space station, because you can,
yeah.
with the right rotational speed that's slow enough with a big enough diameter design, simulate a 1G environment. But of the possibilities that we have off Earth, Mars is about the only thing that could come to a reasonable gravitational equivalence to Earth that we could actually consider terraforming. So clearly there would be health considerations. People don't recognize that living on space stations and what have you in low G has many health implications. Over time, the skull starts to reshape the bone growth, and this can actually compress the optical nerve and can induce blindness. And there are many things that living in a low G environment pose health risk to humans. So clearly, Mars is as close as we're going to come of anything that's currently available in our solar system that is a natural satellite or planet. But to get to something that could really equivalent to Earth living conditions would have to be an artificial satellite, such as Jerry Stone has proposed, as Werner Grandel, and of course Gerald O'Neill some time ago, the real pioneer.
Yes, and yes, this is clearly a subject for the Living in Space SRI committee and the initiative that we are carrying on together. And in view of our Congress next year, of course, the fourth SRI World Congress, where the Living in Space subject is one of the key discussion symposium. And so we are preparing papers for that. We are preparing articles. We are preparing webinars, and we are very, very active on this point. And yes, so I come to my questions that I wanted to propose to you. Some of them, no, all of them are technical questions, by the way. And first of all, is what is the status of the technology? Is that would it be ready just to be engineered in a bigger scale to generate magnetic fields? Is there a technology almost ready to be just to be validated by proper demonstrators and so on, or is it still to be theoretically conceived?
Well, I mentioned already the article that I did with Jim Green, but in the same series of articles, there's another article that I did with a colleague at Michigan State University that talks about, if you will, a series of possibilities of generating a magnetic field systems that could protect people on the surface of Mars that would be for just a 1,000 meters or a kilometer area surface. And that there's two aspects to this issue. One of them is protecting the habitat from solar flares and CME events, but also to generate a magnetic field that is consistent with human health. That actually, there is two articles in the Frontiers article, one by Professor Barnes from the University of Colorado, and then my article with my colleague from Michigan State University on creating a series of protective shield systems. So go and ask your question. I'm going to try to answer this call from Dale Smith, who maybe has a question.
Yeah. Okay.
Hey, Zoe, I'm actually on a thing. I'll call you back in about 10 minutes or 15 minutes. Okay. 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 All right.
Yeah.
All
so
right. Okay.
Going ahead with my next question. Yeah, I understand what by your answer to my first question, I understand that there are different technical solutions because yeah, when you talk about protecting an area of 1,000 meters diameter on a surface, You are not thinking about a satellite
No,
system.
no. In other words, we can do some of this on the ground, and but it would we would perfect some of the techniques that then we would transfer to satellites. So
Okay, okay, okay.
the
I see.
idea is that this could be
I
done
see.
much lower cost and to perfect. So it's walking before you try to run. So testing some of this out in terms of terrestrial applications first before we try to implement it using satellites in space.
Yeah, and also it comes to my mind. I think that one problem is to protect a planet like Mars. No,
Right,
you have to think about I don't know how many satellites all around generating the magnetic fields or something like
right,
that. They will need to be fed, of course, power supplied.
right,
And another thing is to protect an object in free space, like an habitat, an inhaler, torus or cylinder, uh, dimension of some kilometers, let me say. Then, of course, we cannot put satellites around an object in space. But we have, however, to generate. How could it be possible to generate the magnetic field from inside the habitat? Or should be, however, done outside at a certain distance from the object itself. I don't know if
well,
I
there's several
yeah.
designs. Most of them, in terms of what you would do on the ground, would be outside the area that would be a series of two dipoles that would then generate the field.
Okay.
But
So we have to see some pictures, yeah,
right,
in order to work
right.
with our minds. And okay, my last questions. Uh, which kind of power feed are we talking about? I mean, s- uh,
Well,
what size? Which size?
at the biggest level, that would be actually generating of a plasma type of effect that is discussed in the article that I
Wait,
cited in
wait,
my
wait, 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 sorry. When you talk about plasma to make an artificial Van Allen, I
right.
think it's something different, physically different from an artificial magnetic shield,
Right,
right?
it is, but in other words, it would be a hybrid. A part of it might be a plasma generated field that would be part of the design, and other parts of it will be satellites creating dipole systems that would combine with it. So it would be a hybrid of
Okay,
plasma generated from maybe both of the Mars satellites, plus a series of artificial satellites that would be spaced so that you would create a continuous supplemental field. So this is not a easy thing to show or depict, but it'll be interesting, this hackathon contest, to see what people might be able to come up with in terms of a design that would work just using artificial satellites, because in the hackathon we are not addressing the plasma generated from the satellites as a part of the contest.
yeah, I think it will be very, very interesting to prepare the statement of work for this hackathon.
Right,
And
right,
for sure, we will work together, SRI and ACES, to do that next year. Maybe we can see what we
right.
can do. And but however, I understand that nobody so far made calculations about the size of the power supply needed in terms of megawatts or gigawatts or what else.
Well, what we say in our article, that until there's any uh, serious space agency effort to undertake this, we thought it was premature to try to go into developing the design. That there has to be some buy-in to that this is something that could be done, and that would be something that a space agency would take seriously enough to start a program. And at that point, we might start doing the feasibility of engineering. So right now, we're pretty much at the theoretical level.
Yeah, that is maybe premature for them, but not for us. Because we want to start civilian space development as soon as possible.
Right.
I think this is one of the priorities
Right.
to go ahead. And maybe also to stimulate to produce at least a demonstrator, no?
Right.
A demonstrator in orbit to put there, let me say, a small space station, like not big like the ISS, even smaller, but just to see if we can really protect it with by means of a generated magnetic field.
Well, I've actually pushed. I'm actually helping to fund the hackathon event. That, to me, this was kind of an interesting way to get started. And if some of the designs seem interesting enough to try to test, that would be the next step that I would like to see done.
Great. And I will also call now, since, okay, this is a preliminary webinar for our World Congress, everybody that is starting to think about that, to work in their mind on this subject, to maybe submit an abstract for our Congress. I will now I will post the link to the abstract submissions for the Congress in the chat here.
Right.
Okay, let's go ahead. Maria, is there anything else? Oh, I see some. Yeah, can you, Maria, can we pass the questions to Joe?
She's still muted. There she is.
Yeah, somebody still wrote something. But I am afraid Maria is having some connection problems.
Yeah, I'm here, but I'm getting disconnected every then and it depends. I don't know.
Okay, so okay, I will read what people has written in the chat.
Thank you, Ade.
Rob, no, Bob, sorry. Rob says, wrote the increased solar storms are being caused by our returning binary star. I don't know what it means. The Earth is tilting, the core is rotating backwards. Per class solar flares are increasing, causing increased volcanic activity. Well, I don't know anything about that. And Jerry Stone wrote, apart from standard radiation from space, there is also cosmic radiation. What would you say about that kind of protection?
Right.
Oh, yes.
Well,
It's a
right.
good.
Well, truly, there are a number of cosmic dangers. I gave a talk yesterday when I asked everybody how many people here had traveled millions of miles into deep space, and only one person had the intelligence to raise their hand and say, me. And of course, we, all of us on planet Earth, go about 600 million miles or a billion kilometers around the sun each year. And in that travel, we have the dangers of being hit by potentially hazardous asteroids, by comets. A Phobos will come very clear by Earth within the moon orbit, striking Earth, and that would be a very catastrophic hit because that is over 300 meters in size, and 35-meter asteroid can wipe out a mega city. In other words, 35-meter hit on Beijing or Paris or Mexico City would destroy more than 10 million people. And a Phobos at over 300 meters is not 10 times larger, but 1,000 times larger in mass. And so that could do incredible, dangerous impact on our planet. And comets, of course, are even more difficult because they come in at different angles and at much greater speeds. And so a comet, if it ever hit Earth, would be a tremendously dangerous thing to occur. We did witness what happened with the Shoemaker comet when it hit Jupiter. That would have probably destroyed Earth had that event happened to hit us. Unfortunately, the massive fields of the Sun and Jupiter and Saturn protect us from asteroids hitting Earth. But it's not only radiation and cosmic, coronal mass ejections, but there is indeed cosmic rays and other dangers that we pay very little attention to and that people don't recognize. We do live on spaceship Earth, and that there are all sorts of cosmic hazards that we need to have a much better planetary protection system. Fortunately, the UN did agree to create the International Asteroid Warning Network and also the Space Mission Planning Advisory Group with regard to asteroids and comets. But we really do have very little work going forward to deal with coronal mass ejections and other things, even just leave it there, that we need much more of a effort to protect Earth from cosmic hazards. We try to say we're smarter than the dinosaurs, but we have very little proof that we have actually said, hey, we know enough about cosmic hazards that we need to do more to create a defense system against all sorts of cosmic hazards.
Yeah, definitely. Okay, so let's see if we have anything else. No, we don't have other things. So I believe we could maybe close.
Right.
Not before remembering what will come next.
Right.
So our next webinar will be, let me check the calendar. Let me check the calendar. Next webinar will be the 3 of November with Thomas Matula, the civilization survival scale and space settlement. That will be another very interesting webinar. And of course, the 13th of November, we will have the Living in Space event, a workshop with several speakers talking about living in space in a 360 degrees understanding. So what is our next future? What we
I
have?
just urge everybody to go to the living-in-space.org website and sign up to attend. We have, I think, a dozen speakers from around the world who are true experts in various things, from transport to space habitats to space health and living conditions. and some very, very good speakers indeed.
Great. So thank you very much, Joe, for being here today with us. Thank you, Maria. Even I'm sorry that technology didn't support us today. However, yeah, we'll see next time, our next webinars. And ad astra.